Let's start with this problem, which is a quite important problem. Problem 98, chapter 2. Here we have this particle which starts to move from point A at time is equal to 0. It starts from point A and it starts from rest. There is no velocity at point A. And it's going to go to B, then it's going to go to this curve and move along this curve. It says the speed of this particle is going to increase with the constant rate of 2g from the beginning. So the velocity is going to change or is going to increase with the constant rate 2g. It means v dot is equal to 2g all the time, starting from here and also all along this curve. And we are supposed to find acceleration of this particle at point B before starting this curve, and at point B immediately after passing this point and starting this curve, and also the total acceleration of the particle at point C. So the first part is quite easy. From A to B before starting the curve, this particle is moving just on this straight line, and acceleration of it is going to be just v dot. So acceleration at point B is going to be equal to v dot, which is equal to 2g. So it's going to be 19.62. Because there is no curve, acceleration is going to be just on this straight line. There is no perpendicular acceleration. So 19.62 meter per second squared. And also the question is asking about the direction of it, which I'll let you figure that out yourself. But the first part, the direction is going to be just in the horizontal direction. In the second case, which is the same point, but we are assuming this particle have started this curve. Here we have a curve path. Because it's a curve path, acceleration is going to have two components. Tangent to this path, which is going to be this, and also normal to the path, which is going to be toward the center. So acceleration has two components. Acceleration in the tangential direction is always equal to v dot, which is equal to 2g here. And acceleration in the normal direction is equal to velocity at this point, velocity at b squared, divided by the radius of curvature. And for a circle, the radius of curvature is the radius of the circle. Let's call it r. So I need to find the velocity of the particle at point B. If I do that, I can put it here to find the acceleration in the normal direction. How can I do that? We can actually figure it out from the first part. The particle is moving on a line, it starts from 0, and we want to find the velocity of it here. I don't have any information about the time here, so probably the easiest way is using time-independent equation between A and B to find the velocity at point B. Because acceleration is constant, I can write velocity at b squared minus velocity at a squared is going to be equal to 2 times acceleration, which is 2g, times the displacement from here to here, which is 3. And velocity at point A is equal to 0. So velocity b squared is going to be 12g, which I can put it here. So from these two, acceleration in the normal direction is going to be 12g divided by r, which is 3.5. So this is acceleration in the tangential direction, and this is acceleration in the normal direction. The total acceleration is going to be a combination of these two vectors. So acceleration is going to be equal to the magnitude of it. It's going to be a square root of at squared plus an squared. Which, if you put the numbers, this is going to be 38.9 meter per second squared. Okay, and the last part, is asking about the acceleration at point C. Again, at point C, the particle is moving on a curve. So acceleration is going to have two components, tangential part and also normal part. Acceleration in the tangential part at this point, at point C. Acceleration in the tangential part is equal to v dot, and we know v dot is constant all along this path. It is 2 times g. And acceleration in the normal direction, in this direction at this point, again is equal to velocity at this point divided by the radius of curvature, which is r here. So I need to find the velocity at this point. So what is the velocity at point C? How can I do that? How can I find the velocity at this point? Like what how I explained it in the previous video, we have Vt here, right? We have V dot here, or At. You can assume this path is just a straight line and write all the equations that we had for a straight line by replacing acceleration with At for this curvy path. For example, to find the velocity at point C, I can write the time-independent equation between A and C. What's the meaning of that? It means velocity at c squared minus velocity at a squared is equal to 2 times acceleration in the tangential direction times the displacement from A to C, or length of A to C curve, right? So if I grab this path and stretch it and make it a straight line, the displacement from A to C is going to be the length of this path. Or you can write the same equation between B and C. It's absolutely up to you. Then in that case, we are going to have VC squared minus VB squared is equal to 2 times AT times the length of the arc BC. Both of them are going to give you the same answer. So if I want to use this version, velocity at c squared minus velocity at a squared, which is 0, is going to be equal to 2 times AT, which is 2g, times the length of the path from A to C, which is 3 meters here, plus pi divided by 2 times r, the length of this quarter of the circle. So pi divided by 2 times 3.5. So we can find the velocity at C using this equation. And if you do the math, velocity at point C is going to be equal to 18.26 meter per second. Now, after finding the velocity, now I can plug it back here to find the acceleration in the normal direction. So acceleration in the normal direction at this point, at point C, is going to be equal to VC squared divided by R, which is going to be equal to 95.3 meter per second squared. So that's the acceleration in the normal direction, and acceleration in the tangential direction is still 2g, or 19.62. And if you add them together as vectors, you're going to find the total acceleration. And the total acceleration is going to be equal to an squared plus at squared, which is going to be equal to 97.3 meter per second squared. So this is how we can find the accelerations at different points of this path.